pig binder anywhere, like hot pig.
Yeah,
No,
it was right.
but I haven't been looking.
It was on there.
No, it was like a 1-inch pig binder.
Why is it that when I go to start class, you all have now lost everything important to your life?
No, I can't find it.
All right, we ready to start class? No, my soul is missing. Take a moment, find whatever you're looking for. Where did you last have your hot pink
No, I
binder?
picked it up home and I can't find it.
What?
Mr. Hudson, I have to read the rest of this volume.
No.
Wait, you read volume? You listen to volume.
No, it is a volume of the book series. He is correct. All right, homework. It's up on the board. Chris Richner, this video is for you. I hope you're enjoying your choir day.
Probably not watching
And the question is, all right, so Chris, if you watch this video and come tell me that I said purple aardvark, you will get a prize. Nobody tell Chris, okay? Let's see if he actually watches it.
Wait, the thing is, you can't put it at the beginning because if he starts watching it, then stops.
Chris, there's going to be a different code word embedded somewhere in this video.
Time frame. It'll be a timestamp 5:52. So just look there.
No.
Got it.
Lies.
I'll tell
All right, there's your homework.
you. At the,
Camera's over there.
if you
So-
go to the end of the video, I'll shout it out.
So today,
Camera's over there.
I want to see how comfortable we really are with this stuff.
I really
So, we are starting to look at special cases, which we really started yesterday. But I want you guys first to just work through A through L, and this is supposed to be like this cheesy activity where you go around the room and there's different things, which is like, okay, that would work fine, and especially if we had a bigger class and if it was like the regular Math 2 course. Like, that would all be fine. I'm not like talking down about CPM in that way, but for you guys, kind of thought it'd be better if, now don't work these in order, so listen to instructions before you really dive in. What I want you doing is, and you can start with A and then go from there if you want, like, but I'm not saying go like A, B, C. So if you start with A and you look at trying to factor that, A is going to be an easier value to factor, and we talked about some cases like this for the past couple days when we're missing the BX. Right? And when we're missing the BX, there's two options. Either something really bad has happened, or it's a difference of squares. Right? So difference of squares, that's still that vocab that we're driving. And because we see it's a negative 49, my second square is negative, we can assume it's going to be a difference of squares. So I want you to then look through and see, are there any others from that set that match that type of quadratic?
Wait, set?
In fact, of A through L, of this set of quadratics that we're looking at. So, now I'm not saying like do it right now out loud. I'm going to release you guys to work on this. And solve all of those. Whatever you think matches that type of solution, do all of those. Then, B is different, right? It's a different type than A. It has a BX value. Factor that out and look for any others in this set that match that type of quadratic that we're trying to solve.
Would K be?
So basically, just do the order things in different order.
That's for you to figure out, right?
You
So
said something about
as
negative and difference of squares.
So as you go through and you try to use the fact that this is similar to that, let me solve it similarly to that. Like, you're going to find out how these similarities and differences change how we can factor and find those zeros. So I want to give you at least 5 minutes to just factor these out, to just work them and like group up what is similar, and then we will talk through, even though they look similar, what was different in the solution process. Or what rules were we allowed to apply in either way. We talked about one rule yesterday that I don't want to remind you of yet. I will once we really dive into these. But I just want you to take like 5 minutes to try these out. Do this on your own for a couple minutes. Don't talk to each other like at all, because I think that clouds your brain a little bit and doesn't let you think independently. So let's even just do like, see if we can do 3 to 4 minutes of just silent work. And I'm uncomfortable with silence, right? But this is to let your brain engage in this. I gotta go with Mr. Cavilla for a minute. Please try to keep working until about 48, 49, at least on your own, and then start discussing what you found with each other. Okay? He needs somebody to relieve him for a moment so he can get with another group. So I'll be back with you guys, but I might have to bounce back and forth today.
The answer is J. Natural perfect square.
Like which? Like which do you?
Okay. Could you match
Well,
this?
you tell me. Because the difference between C and K is that C actually has a Bx value that uses that outer and that inner.
But then,
Which is why perfect square trinomials have to have a Bx.
but like when you get a perfect, like.
But imagine writing that out. X minus 5 times X minus 5. Your outer and your inner terms don't cancel each other. For this to happen, your outer and your inner terms have to cancel.
So what does this be called?
This is perfect square.
Yeah, it is.
Yeah. This, I'm not telling you yet.
No, we learned about that yesterday. It would be a perfect square because you could just take x plus 2 and put that in.
Can you?
Yeah.
Check it. This is for you to figure this stuff out without me, really. Do we want more time on our own?
Why don't we just do it?
I'm not done at all.
I gotta make sure my computer's not gonna restart. Well, if they wanted to run updates. I will tell you, not every single one of these can be factored. You could have inferred.
Wait, doesn't mean I didn't spend 6 minutes trying to figure that out.
Wait, what?
So let me pause you for just a moment with the one that I think you're probably most frustrated about. What is x squared? What do we know that makes? Well, yeah, but so if we visually, graphically, like x squared, parabola, right? It's your standard parent form of a parabola. Big old U, right? Kind of a sharper U than what we're used to. So x squared plus 4, what change has been done to that graph?
The y-intercept.
The y-intercept. If the factored form tells us the x-intercepts, and this has just been shifted up to 4, are there x-intercepts?
No.
This can't be factored.
Yeah.
What?
Because
You
there
didn't even
are
do it.
no x-intercepts.
No, it can't. Try it.
So, if what you're thinking
-2.
is that it's going to turn into x plus 2 squared,
No, it wouldn't.
there would also have to be a 4x in the middle.
Yeah, because 2 would multiply by x.
This is what a lot of you got wrong on the mastery. I think the first mastery is
x plus 4.
Yeah.
like I'm trying to figure out when that's going to fit in this week because
Oh,
I
yeah,
want
you
to
might
review them. No. Okay, that's like okay, let's chill. I know you need to finish. We talked about this once. I tried to give it to you and you didn't want it. Except, yeah, I asked you if you could finish it at AOR Extensions and you said something about being super busy and then like you walked away.
Oh yeah, I had orchestra.
I know, but I'm trying to give it to you to finish elsewhere. You don't have to be right
What
here.
if I do?
But so a lot of us got this wrong because this doesn't mean square the x and square the 2. It means square the expression. So x plus 2 times x plus 2, we'd have a 4x in the middle. This
So use
is
the FOIL
not
method?
factorable.
You use the FOIL method for that dish.
You can. That is one method of doing your binomial multiplication. So k is not factorable. Knowing that, take a couple more minutes to try to figure these out. And then I'm actually going to ask that we then, after we talk with each other, come up and, well, not like all of us, but like one at a time or whoever feels like they have good stuff to share, come up and explain to us what you have discovered. Like what of these are the same and what of these are different. I'm going to guess you're totally factored out, Jacob.
Yeah.
How much longer do we think we need? Like 2 minutes? I mean, do we need a whole lot of categories? I don't know.
Oh, I thought we needed. Everyone has one that matches, right?
I didn't say that.
Yeah, you did.
No. I said find ones that are similar, like look for similarities and differences.
Oh, I keep going.
So if I look for like, I want all trinomials that have a negative b value. Okay, I got a few of those. But then if I want all trinomials with a negative b value and a positive c value, that limits my options to like c and g. If I want negative b and negative c, I can match up e and I. And that seems to be it. If I want positive everything, positive a, positive b, positive c, I got D to choose from. I got J to choose from. Angry monkey. I'm about to download some app on Gold Range phone so when she's here the ringer turns off. What?
I have my ringtone up so
I know, I was just talking about
I don't
downloading
need
an
to tell
app
you that. You're-
that when you're here in this building, it will like turn off your ringtone automatically.
It is called. What?
What did you?
It's the bottom corner. If you move your cursor to the bottom corner,
Pages.
Like chosen.
it's up on the TV.
That's hard work.
So, one category we already started talking about is difference of squares.
Squares.
Yeah, my letters are very tight together today.
Use the other font.
What the heck?
Use the other font. Like
You
the
did
fancy
this.
font.
It keeps switching on its own for some reason. All right, x squared minus 49. And once we get a little bit more complicated, I might have you guys come up here. This should be easier, right? Since we know that this is negative, and we only have a coefficient of 1, and I can start with that, and then, well, 49 is a square, so 7, 7. Here's why they're called difference of squares. The outer and the inner cancel. Because we have positive 7x and negative 7x. So the only things that actually matter here are the firsts that make your x squared, and your lasts that make your negative 49.
So would the zero value be 0?
No, the zeros, like where it crosses the axis, would be what makes this 0.
Oh,
Well, negative 7. What would make this 0? Positive 7. The graph is still pointing upward. So we know, and this is like beyond what you need to know right now, but if we try to analyze what's it look like, negative 7, positive 7,
How do you know?
this, negative 49. Right? Because we know that. We know all of that just from this.
Wait, how do you know if it's up or down?
Because this is still positive.
Oh, if that's negative, it'll
If
be
this
down.
coefficient, and we played with this in Desmos a little bit, but if I make the coefficient of x squared negative, it flips it.
Oh.
So remember, changing A changes the behavior of your parabola. What direction it's facing and how tight it is. So like the intensity. B, as I change B, it moves my parabola in a parabolic fashion. Like it would follow that line and move. As I change C, it moves up and down.
How do you make it go like sideways?
That you set up that x equals y squared. Think about it. X input.
Oh, it'd just be the opposite. So you change like everything to y?
You flip around your input output.
Oh yeah, so there were 2 y's on one.
So another difference of squares, not k, because we said k does not work. X squared minus 36.
And I mean, no, and
What's this come out to?
X plus 6 times x minus 6.
So then 9x squared minus 1.
Wait, if you draw a line between all
3x
sixes
plus
and
1,
create
3x
a triangle.
This is not the Illuminati.
3x plus 1.
3x plus 1.
And there's an x in the middle.
3x minus 1.
6, 6, 6 triangle.
Please focus. Any questions on our difference of squares? Oh, I missed one.
Yeah.
4 squared.
What's this come out to
2x
be?
plus 5.
2x plus 5 equals 2x. Why are you so fast?
It's not equals.
I mean, times.
Yeah. Fool. Get it right.
Any others that we missed? Let's look at all positives. I like purple better.
Purple.
Just because it's more fun. So, D, right?
That'll be 4 times D for tongue.
Anybody want to talk it through?
Ooh.
Jacob? Because it'll pull you away from your book for a minute.
Okay.
Thank you, sir.
So to make the 9x, you probably go 3x.
Now, why are you choosing 3x and 3x instead of 9x and 1x?
Not that big of a difference.
No, I'm talking about 12. Like,
The
it's
12
not that far
was-
away
yeah,
from
it
0.
would be,
3x times 4. You're gonna do 9
Let's
times
see,
whatever
so-
equals 12.
with 4, it would have to be either like 2 or 4, and to multiply. If you did
You can make
4 times like 1 and then 9 times, if you did 4 times 1 and 9 times 1, then that would end up as 13 and not 12. And then if you do 3 and 3 and then 2 and 2,
This
then
diamond
it
thingy.
has,
more than rectangle.
so then it would be plus 2 plus 2, which makes it
That purchase is plus. perfect square?
Absolutely. So if we try to go down the road of 9x and 1x, this would, in my head, potentially mildly work.
They're all perfect. Wait, what?
What? Let me finish sentences.
Oh, never mind.
Like, in my head, when I first start thinking, okay, I have two options, right? 3x, 3x, or 9x, 1x. As I think this through, this and this have to give me 12x. My options here are 4, 1. So if I go 1 and 4, well, crap, like Jacob said, that gives me 13, not 12. And if I go 2 and 2, well, that's way far off because I know that I have all positives. So these have to be positives. And that's 20. So none of that would work. So if you tried the 9x and the 1x, you should be able to talk yourself out of it, saying like that doesn't work. So then the 3x and the 3x do work out well when I use the factor of 2 for my 4, and then it's perfect square.
Isn't it like b equals double the root values that are, so would it be like 3 times 2, and then you double that to make sure if it's perfect square or something?
Here's the problem. I want to name those like A, B, but that's not really because we call these A, B, and C.
Yeah.
So this is really
Okay, yeah.
sorry, not B, C.
Why don't you want to name them C though?
Because this is the square root of C.
Yeah, no, but why said like I really don't want to name them A, B, and C?
Well, I was going to name this A and that, but it's not. It's square root of A, square root of C. If you can recognize, and this I dropped this real quick yesterday, that the middle value is double the product of the square roots. Easy peasy, you know it's got to be perfect square. If not, then it's like, even if that's a perfect square and that's a perfect square, it may not be a perfect square trinomial if the middle value doesn't work.
Aren't there other perfect squares that aren't all positive though?
What do you mean?
Sorry, just
Oh, hang on. Yeah. So if we have a negative, we can still do a perfect square with a like 3x minus 2. But so let's talk about another situation that we might encounter just to reiterate that. Perfect square, all positive, but this, let's say, is 20x. We already talked about how that would factor.
9 and 1.
Right? 9 and 1, and then the 4 and the 1. Or no, sorry, the 2 and the 2 is what we used for that. So if we then here, this would be 9x, and that's the factor form of that. So even though it's still perfect square, the b value doesn't match. Other all positives up here. J.
K's all positive. Do that. Do K. But
D, J, and K are all positive.
Can I factor anything common out of all the coefficients?
1,
Okay, does not count.
2 and 2.
Yeah, it doesn't work. So let's try. If I do 2 and 2, then I know that these can't be like 5 and 5 probably. Wait.
They can't.
Wait, what? Yeah, you're right.
So here's why solving quadratics is so complicated. When we talked yesterday about, okay, look at your b value and see like how dramatic it is, how far away from 0. Like that's going to determine whether I break this up into 2, 2, and 4, 1. This is still not very dramatic. Like 20 is not that big.
Oh.
So we can think through, well, if I make my life easy, because there's not that many factors of 25, does this work? Yeah.
25.
Is there any like real confusion to what we're doing here? Like, please be honest. Now we can use the diamond method and we can use the rectangle method, but sometimes we just don't have to.
Oh, you could have done the whole like 2 times 5 times 2. We got 20 and realized that that's
Square root, double.
We still do that method if you make it understand that way.
Oh, you want to see that one then?
Yeah.
So this would become
That'll just be the regular
100x squared, right? And this is 20x. What two values will add to 20x and multiply to 100x? 10x and 10x.
You're a genius.
which then, if I set up,
It's a smashed window 5. Excuse me.
then we can get it from there.
Look at my diamond though.
Questions? Nope. You set up the diamond, the values on your left and right tell you the diagonal boxes. And I think that's all positive.
All negative. Okay. Okay, it's all positive.
Let's go funky ones.
Okay.
So, like,
B.
hey Satya, if you say K one more time, I'm going to ask you to leave my class.
Okay.
You're like the guy at the concert, you're like, play Freebird! And he's already said, we're not playing Freebird anymore. Like, just stop. I was trying to let it figure itself out, but you were continuing. So, I have a negative value for my C, but a positive for my B, which tells me to have a negative value for my C. I gotta have a positive and a negative. It's the only way to produce a negative. And then I know X and X. So that's where we should start at a minimum. You should at least be able to get there.
6 and 4.
Then we're thinking through factors of 24. Because guys, even if you're in here and you're like, oh, I got this, I'm excelling at this. Like, not everybody in this class is, I guarantee, because factoring quadratics is not that easy. So we think through these factors until we find 2 of them that are 2 apart from each other. Ding, 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 ding. 2 apart from each other. Then we decide which needs to be the positive and which needs to be the negative based off the middle value.
Why do you say that that's funky?
Because it wasn't all positive or all negative. I just wanted to name it funky. I don't know. One of them's positive, one of them's negative. So to flip it around then, if we look at C.
C is a perfect square.
All right, we already did C.
We did?
That's the only funky one.
Oh, yeah. E. G.
Yeah, C is x minus 5 squared.
G.
What haven't we done? G?
G is...
X squared minus 6x plus 9?
G is pretty easy. It's just another perfect square.
G is a perfect square.
Yeah, it is.
I said it is.
It is.
Oh, yeah.
Well, you should also recognize that this is a perfect square. Square root of our perfect square. But if we make it negative, my outer and my inner make my negative 6.
Math. Oh, yeah, why did some people say math?
Because that's what the rest of the world says, because math is actually abbreviation for mathematics, which is plural because there's multiple branches.
I like mathematics.
So it's maths.
I.
I call it math.
I's kind of funky, right? Because it's got a 7. 7x squared minus 20x minus 3. Now, did we avoid this or did we solve this?
I solved. Wait. There's no common. I solved.
What does the 7x squared immediately tell me? Thomas?
7x squared?
I can tell you're either like doing tonight's homework or something else. So, what do I know based off just looking at this initially?
That it would be. Don't you mouth answers on it?
He's not even looking at me.
See what I did.
So, what are the factors of 7, Thomas? 7 and 1.
Four
I
and three.
have. Shh, guys, you're being really rude. To, like your classmates and me. Now, I don't really care that much, but I want your classmates to be comfortable. Then the negative 3. I'm teaching you how to analyze and break these things down. If I have a negative product out there, one of these is going to be positive and one of these is going to be negative, but I have to be able to determine why I'm going to put these things where I put them. Can anyone tell me how I can make that choice? Where the positive goes and where the negative goes? Thomas, I'll come back to you.
Since the 20x is negative, then negative overrules, and so the negative would multiply by the larger, which would be 7x.
The negative needs more, right? It needs to win this battle. So I need to make sure that the negative gets plenty from the outer inner, and that the positive just brings us back to what we need to be, because these are going to battle with each other. And when I think through my factors of 3, well, I'm pretty limited.
Is that possible?
Is what possible?
Yeah, it's definitely possible.
Negative 21 plus 1 gives me negative 20. Last gives me negative 3, but I already knew that because I thought through those factors before I plugged them in there. That's your factored form of this. Does this? These are the harder ones. Actually, it's really hard when this is not perfect square and not prime. Because then you have options of factors. Yeah.
How do you know when an equation or like those things are not factorable?
You try a few things, you get frustrated, and you decide they're not factorable.
Once you've done it for 10 minutes and want to claw your eyes out, it's probably not factorable.
I've never wanted to
Well,
call
I
my
know
eyes
you've
out.
been doing it right, and it's still wrong. It's not
Like I
factorable.
went to college.
Yeah. I mean, essentially, when you try what we know works and it doesn't work, it's not factorable. So we could have, like, say in K, because I'm guessing that's kind of what you're asking about. We can do the diamond method, and we'd have 4x squared, but then the sum is 0x. So for this to work, I'd have to have like a positive and a negative, right, to sum out, and there's no way that this works. This is impossible. To have a positive and a negative produce a positive. This can't, like, so that tells you right there, like,
Negative, positive, 2.
this is broken. Because actually, the zeros are imaginary numbers, which we will get to.
Oh yeah.
And they're not actually imaginary.
Are
they're
those just like
complex.
tests? Oh, I just always get like I and then a number. Is that what that means? Imaginary 36.
What if we choose
Anything else in 45 we need to go through?
Yeah. That took all of the whole class.
Yep.
Wait, you make it negative here.
Do we see any of these that right off the bat are not factorable? And I want to know how you know.
Right? Yeah.
Steve and YE, we haven't really talked today.
Because if you do the diamond thing, they have to, what's it called? The bottom.
So I'm going to stop you because don't use what I just told you. Do you have another way of knowing that it's not factorable?
Not really. Try it out.
Hunter?
the top needs to be positive so that, because the two factors have to, one of
Yeah,
them
but that's
has
what I just told you.
Yeah.
What other way? Like, you're right. You're not wrong.
the parabola doesn't ever reach the x.
Yeah. The thing that, what did the 9 do, Hunter? Yeah, it tightens up the parabola, right? It brings it in so it's steeper.
And then the 4 raised it up.
And the 4 moves it up. It doesn't cross the x-axis in our 2-dimensional graphing that we're used to. But in 3 dimensions.
I'm gonna cut you off.
Stop it.
Satya might kill me.
Cut you off right there.
We're just
Tom.
gonna stop.
We need to. Oh, Christopher. Iridescent elephant.
Iridose clay.
That's your secret word.
Iridescent
Say
clay.
it.
All right. So real quick, let's see how good we are at
Iridescent
these.
elephant.
What's a factor out? Actually, here, I'll give you a 10-second head start on each of these. Factor A.
What?
Factor A. We said it can be factored.
5x
5
minus 1
seconds.
squared.
Shh.
Gantia.
He dies at the end of the movie.
Oh.
Stop it. Class. What? And you're also wrong.
Oh,
Class,
yeah.
what is it?
There'd be an X
You're
value.
actually wrong, though.
Yeah, there'd be an X value.
Bruh.
It's a difference of squares. Stop trying to work so fast. Think, man. Turn on your brain. B factor it. 10 seconds. Don't say it out loud. Ooh, you're probably going to need more than 10 seconds on this, aren't you? If it's a negative product, means one of these is positive and one of these is addition, one of these is subtraction, right? X and X. Think of factors of 36 that have a difference of 5. Okay, pretty quickly in my head, I come to 9 and 4.
Wow.
Our factor is... Now, which one needs to win, the positive or the negative?
Negative.
Negative needs to win, so he gets the more power. There we go. Like the stronger, the what, like, The negative gets the bigger number, whatever you want to say. Like, so with my 7th graders, I've now been teaching positive and negative addition, and those skills is like they fight each other, who has more power, which they don't know exponents really yet. So when I talk about like power or strength, it's easy to say 9 is stronger than 4. Whether they're positive or negative doesn't matter. 9 is stronger than 4. So 9 gets the stronger position, or the negative gets the stronger value, so that the negative wins out. C, 10 seconds. What do we get?
4 and 2.
Yeah, x plus 4 squared.
So if it's all positive, it's the most likely going to be a perfect square.
Not most likely, no. But perfect square, square root both of them, multiply them, you get 4, double it. That's how you know it's a perfect square. Square root, product of them. If the b value is double that, you know it's going to be perfect square. 9x minus 12x plus 4.
Oh, that's a... Yeah, it's a
Perfect square.
okay.
Yeah. So,
You spoiled it.
3x
No, plus 2. Plus 2.
minus
Oh, wait,
2.
no.
Right?
I have it down
Because-
as minus 2, actually. I have it down as minus 2, but I said plus.
Be careful. It is perfect square, but if we write, sorry, so this wouldn't be there if we write out both.
Yeah,
But if we only write out one of them, it'd be 3x minus 2 squared, but I wanted to make sure you guys think it through. Outer, inner, both have to be negative. But then negative times negative produces positive.
He's not possible.
Not factorable. It is possible.
Yeah, it's not factorable under our standard. Like, it is factorable if we know how to use imaginary numbers. But we don't yet.
Under standard, which we do not know.
Ha! Would that be dramatic?
Satya, would this be a perfect square? Dude, you should be able to answer that.
It's a
Like
difference
that.
of squares.
It
Yeah.
can't be perfect because this is negative,
Yeah.
right? So, but you were just like staring at it. You didn't give me an answer. So it cannot be perfect square. It has to be difference of squares, right?
Yeah.
We're missing the b value. It's got to be difference of squares. It cannot be perfect. Whatever.
Isn't there like a way
So
like
first
you can
say that
idle-
word tomorrow.
You're a
Artificial
decent elephant. All right, my smart board hates me.
Iridocyclitis.
So as long as you are familiar with your difference of squares and your perfect squares, and then we talk about closed sets again. What's a polynomial? Binomial, trinomial, quadnomial. What's a polynomial?
Has many.
Yeah, just multiple, right? Any more than one. So monomial,
Like a
single.
polygon.
Yeah. So polynomial, any expression with multiple pieces, right? So they cannot be like terms. You cannot say 12 plus 5 is a polynomial. Because no, if you simplify it, it's not. So polynomial has to be in simplest form, like you cannot combine any like terms anymore, and still have multiple terms. So if we talk about when is it closed, like a polynomial times a polynomial. Are polynomials closed under multiplication? Are they closed under addition? So start to kind of ponder those thoughts. That's the only thing that we're not going to get to today, is talking more about that. And we will pick this up tomorrow. How many people are going for orchestra again?
Me.
Just 3 or 4? Okay. We'll figure out what to do tomorrow. Have a good day, guys.
Mr. Hudson,
Adios.
what if Chris doesn't watch the video and we trick him to say another word? Do we all
Then
get
it'll be
prizes?
funny. Sure, but I would probably still have to give Chris one at that point, because I don't like singling kids out in a bad way.